Right, let's do part 2. We're now looking at the stem line diagram. Okay, but I'm going to refer back to the PowerPoint. Now, just from the root though, I just realized I didn't say the following. So yes, there's phloem between the arms of the xylem, those 4 little areas, but it's, it's companion cells and sieve tube cells. Okay, then we went over monocot, which you don't know, and now we're looking at dicot stem. The little stem with the little vascular bundles in the ring. So let's go down. Beautiful to look at under the microscope. All right, this will come back to you. So let me just go past there. There's the line diagram. So yes, I asked you just to label everything, but I've now drawn in the cells, and I think you can do that as well, because then I'll give you time, and then it will give you a better idea of what's going on. So there is my answer. Just move my mug. Right, so on the outside, okay, I did not draw a waxy cuticle on the root, because remember, root epidermis does not have a cuticle because the cells absorb water. But I have drawn a waxy cuticle that is secreted by the epidermal cells. So sometimes most times there's a one-layered epidermis, but if the plant needs more protection, it can have a multi-layered epidermis. Sometimes there's parenchyma all the way under the epidermis of the stem. Sometimes there isn't. Sometimes there's patches of parenchyma. This is a typical cross-section of a stem. There are many variations. All right, so there's parenchyma. Remember, they are living cells. They can have chloroplasts, but it looks like their cell walls are unevenly thickened at the corners. So I was trying to draw that there. Then below that, you've got all this parenchyma in between here, everything here. And these parenchyma cells are smaller with air spaces, and because they're near the edge of the cell, of the stem at least, they've got chloroplasts. So that's cortex of parenchyma. All right. Then they even give the parenchyma in between the vascular bundles names. Okay, we're not going to go there, but in the middle, where the parenchyma cells can get really big and close together or disappear completely, that's the pith, the center of parenchyma. All right, so sometimes those cells can disappear and then it's hollow. Right, then we've got the vascular bundles in a ring. I've only colored in some of them. All right, so on the outside, where have I done it? Here, the sclerenchyma bundle sheath, those long, thin sclerenchyma fiber cells down the side of the vein. So there they are, okay? On the inside of that, you've got the phloem made up of companion cells and sieve tube cells. Then the yellow that I've colored in is the meristematic tissues, the cells that divide, that's going to make the stem grow thicker, make wood. And I've actually started drawing in little dots there, because what actually happens is that the meristematic tissue of each vein gets joined to the next vein by parenchyma cells in between here becoming meristematic. So you end up with a ring of meristematic tissue, just like the pericycle in the root. But this time, it's not going to make branch roots to anchor the plant. This ring of meristematic tissue is going to make those rings of wood every year, which we call annual rings, extra xylem, extra bands of xylem. Because in the beginning, the plant in the first year just has little regions, little separate veins with xylem. But second year onwards, if it's a plant that's going to grow to become a tree, then rings of xylem are actually formed, and those are the annual rings, or the wood of the tree. All right, so that's the meristematic tissue there. Then on the inside, the xylem faces in the middle, because the water has to go across to the middle of the root and then up. And we're going to talk about, to end off this section, we're going to talk about how water can very easily move up against gravity. Okay. All right, so that's the xylem over there. And I think I've mentioned everything now. So what I want to do now is just go back a little bit. So we go here. That's a young stem. So that little seedling your mom bought from the nursery, and now you've planted it in the garden. Now some plants only grow for a year and then they die. Okay, the stems would look like that and nothing else would happen. They won't become wider. They won't make wood. All right, so that's what we've been talking about up until now. And it says primary phloem and primary xylem. Well, that's the xylem that was in the vein at the beginning and the phloem that was in the vein at the beginning. But in the second year, wood is going to be made. Well, how does that happen? Well, remember on the previous slide, I said that there's meristematic tissue in each vein. The parenchyma in between also becomes meristematic. So now you end up with a ring of meristematic tissue. And we don't need to know all these words. And you end up with bark being formed on the outside. We don't need to know these words. All right. So here's a diagram to basically show how it happens. So this is in the first year, little green stem. Then it starts to make in the second year that ring of meristematic tissue. And you can see here how it forms a ring of xylem to the inside and a ring of phloem to the outside. And I really don't want any detail here. So there's the first ring of xylem that forms to the, wait, hang on, I need to look at this carefully. So there's the original xylem there of the veins. There's the original xylem. All right, here's they've used odd colors here. Let's just see, this is secondary xylem. And then, okay, so let's make it simple. So there's the original xylem veins from there. There's the first ring of xylem, all right, and a ring of phloem. Why did they swap the colors? I don't know. So I would have done this red, and I would have done the red blue. Makes sense. So basically every year, another ring of xylem is going to be made. So how old is this tree now? Well, you cut it down, now there's no more tree, okay? So it would be 1 year for the original little veins of xylem, 2 years, 3 years, 4 years. And then you've got all the phloem being produced. Now they've got the colors sort of right. Then you've got all the phloem on the outside and the bark, which ain't green, it's brown. Okay, so that, and I mean, I looked really long for this diagram because you really cannot find easy diagrams. So no detail. First year, separate vascular bundles or veins. Then in the second year, they are joined because you end up with a cylinder of meristematic tissue because parenchyma in between becomes meristematic. Remember, we're only looking at one section through the stem, but you end up with a cylinder of meristematic tissue, which is going to produce a ring of xylem to the inside and a ring of phloem to the outside, and so on every year. So very distinctly, you can see 1, 2, 3, 4 years. The annual rings of wood, the xylem, are very clear. The phloem, not so much. You know, it gets kind of squashed on the outside, and then all the bark on the outside, and the epidermis is gone by now because, you know, bark is made of cork and it's much stronger and waterproof. All right, so that's how you look at a woody stem. Now these little green stripy things going across the radii, that's just little bits of parenchyma, like little channels so that it's easy for water to pass through as well. All right, but no detail for us. None of this. We used to do all of this in a lot of detail. We don't anymore. Okay, so here we have just like mine over here, all right? So, okay, so now the initial xylem would be in the middle. The meristematic tissue is now here. So every year it's going to make another ring of xylem and another ring of phloem, which gets squashed. So there's the first year, second, third, fourth, 5. Oh, I'm getting squished. My eyes are going funny. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Looks like it's about 19 years old. And some rings are much wider than others. And you'll remember I actually showed that to you in my woody stem, and that you can see the bigger xylem cells, the xylem vessels, and the tracheas you can't really see. That's where the wood is more dense. So each ring would have vessels and tracheas. Here it was very rainy, lots of rain in that summer or spring and summer. These annual rings were very thin that year because there was a drought. There's a forest fire, so there was damage, and then the annual ring started growing around it again, and there's all the bark on the outside. Okay, here's a nice one that looks more like mine. So that ring of meristematic tissue is, let's just see, it's over there, okay? Here's all the phloem that's being produced to the outside. There's all the bark right on the outside, protecting the tree. And let's work out how old this tree is. Right in the middle, you would have the separate veins of xylem to second year, third year, fourth year, fifth year, 6, 7, 8, 9 years old. If I do that on mine, it's 13 years old. And we don't need to know about early wood and late wood and all that. Heartwood is just where there's lots of tannins, little like pigments, and sap. Tannin makes our tea colored. Okay, and sapwood is not so hard, not so dark, and that's basically how secondary thickening, growth in width of a plant stem to make it woody. And if I just take one of those annual rings of xylem, that's what it looks like. Now, yeah, it doesn't look like you see very big xylem vessels and smaller tracheids. They look all quite uniform, but definitely if it's a very rainy season, then you get lots of those wider xylem vessels being produced to transport as much water as possible up the plant. Isn't that amazing? It looks like art. Okay, so, oh, here's another one. All right, I forget sometimes what I put in here. So there's the bark on the outside. This is all the phloem here. All right, I know it looks like nothing. But there's one annual ring of wood, xylem, there's another annual ring, there's the third one. Not so much rain this year, lots of rain this year. Look at all those xylem cells and the tracheids. Remember, these are cross sections, and there's the third year being produced. Oh no, sorry. So it would be first year, second year, third year, because that was just made by this ring of xylem. You can see little cells over there. They're going to make xylem to the inside, phloem to the outside, but because of that, the tree is going to get wider and wider. All right, so that's the end of stem and secondary thickening.